I want to talk about uh, safety, working on live mains. I have put a few videos out on power supply repair, and I just got to explain a few things about isolation and current flow. On this diagram I've just shown you your live and neutral wires, and you would have 240 volts AC on between them two lines. And if you put a load in between them, say a light bulb between here and here, you have completed a circuit. So this light will light up. Likewise, if you put one hand on the live and one hand on the neutral, you are completing a circuit and current will flow through your body. Wouldn't be very nice. But also, if you just put your hand on the live at 240 volts, you're going to get a shock off it as well. And the reason being is because you're standing on earth, the floor you're standing on. And when you touch that, current will flow through your body, down through your body, down to earth. Because back here in the power supply, or power station that supplies your electricity, this is going to be very simplified. This would be connected to back into the earth. So when you touch that with your hand, you will get electricity flowing through your body, down through your feet, down to the ground you stand on. Back to this point here at your power station. So what you need if you're working on live mains is an isolation transformer to work a little bit safely. It doesn't prevent all risks of shock, as I'll just point out in the next diagram. Now this is a similar diagram, but we have an isolation transformer here inside that dotted line. Just draw the core. And it's a 240 volt AC in, 240 volt AC out. And you would connect that to your TV under test, which will be your live and neutral to your actual unit on test. Now let's look at if we put a circuit into it. If we put a lamp across here and here, current will flow and light up the lamp. If you accidentally put your hand on that point there, where does current flow? It can't complete a circuit back to here because this is not connected to ground. Neutral here is connected to ground, but because it goes through this isolation transformer, this here is not connected to ground. So you hold that, you don't get a shock like you would if you had held on to this wire. And if you held on to that wire there, if you're in a pool of water, you're in big trouble. It doesn't, however, stop you getting a shock if you put your other hand, onto here, that point. Now you will get current flowing across your arm, across your chest area, and back out this arm, and that could potentially kill you as well. So what we normally teach beginners in classes is to always work with one hand in their pocket until they learn not to accidentally put their hand on the chassis and the other hand on a high voltage supply line. If you're unfamiliar and you're not experienced, I would suggest that's what you do. Keep one hand in your pocket and the other for using your test equipment. Don't use your two hands, that could accidentally give you a shock. I had to explain that because I was a bit worried about people just going out working on power supplies and they don't know about isolation transformers. If you're going to be doing work on power supplies, high voltage, I would suggest you get yourself an isolation transformer. Most workshops it would be required to have a isolation transformer at your bench. Relevant health and safety laws in different countries. And I hope that's of some help to you. Thanks for watching.